so today we're going to move into what we call least common multiple. The first part is a little review. Right, question number 1, write the first 4 multiples of each number. So I know now when I'm going to start with 27, and each time I'm going to add 27 more. So how much is 27 plus 27? 54. Now 54 plus 27, how much is that? What is it? 54 plus 27? 81, thank you. And then plus 27, how much is 81 plus 27? 108. And we could continue, right? Adding 27, it's a never-ending thing. So I'm thinking the list of multiples continues. We're going to stop it at 4. Right, we could go more, but for right now, we'll stop it at 4. Right, so that was the first 10 questions. Any questions on those? No? All right, let me take a look at number 11. Write the prime factorization of each. Do not use exponents. I know 15, I can break it as 3 times 5. And I know my number, neither 3 or 5 can be broken more, so I'm just going to call that 3 times 5. My 27, I know that breaks down as 9 times 3. My 9 can be broken down more, that's 3 times 3. So I'll finish with 3 times 3 times 3. So that's prime factorization. Don't forget to do this one. Like prime factorization, as a matter of fact, for least common multiple, will be beneficial to you guys. Let me take a look at number 21. Well, first of all, any questions up until number 20? No? Alright, now 21. To find the LCM of each, we notice the title of the paper is least common multiple. So that's what LCM stands for, least common multiple. There's 2 ways how to do it. First of all, we can list the multiples. If I look at 36, let me list a few multiples. I know I start with 36. Each time I'm going to add 36 more. How much is 36 plus 36? 72. Let me add 36 more. How much is 72 plus 36? 108. Okay. Plus 36 more. How much is 108 plus 36? 144. Okay. Plus 36. How much is 144 plus 36? 180. We could continue. Let me stop at 5. If probably we're done. Let me stop there. Let me do some multiples of 28. Let me start at 28. The next one, how much is 28 plus 28? 56. Then for the next one, how much is 56 plus 28? 84. For the next one, 84 plus 28? 112. And for the next one, 112 plus 28 is 140. Okay. And I know we can continue. Now my question to you is, do you see a common multiple? Right, the same number in both lists. No? Since we don't have any, we have to make our list bigger. Right, we have to extend it. Looking at the next one, let me start 180. I'm adding 36. How much is 180 plus 36? 216. Let me add one more. How much is 216 plus 36? 252. And I know we can add more, but let me stop it there. Let me take a look at the other one. 140, we're adding 28. How much is 140 plus 28? 168. Well, the next one, how much is 168 plus 28? 196. For the next one, how much is 196 plus 28? 224. For the next one, how much is 224 plus 28? 252. Now, do we see a common multiple? 252, right? So the least common multiple would be 252. Andrew, come here. Alright, so that's one way of doing it. Making a list of multiples, eventually run into the least common multiple. And I call it least because this list can continue more and more, and I can find more multiples. Right? There's more multiples in there, but we're looking for the smallest. So that's one way of doing it. Another way of doing this, looking at 36, looking at the prime factorization of 36, I'm going to get 2 times 2 times 3 times 3. All right, we know we break that out as 4 times 9, and then, so this is 36. 2 times 2, 3 times 3. For 28, I'm going to go 2 times 2 times 7. Right, I'm doing the prime factorization. I remember how to do the greatest common factor. Remember, I used to tell you guys for greatest common factor, look what they have in common. In my case, greatest common factor is 4. Or greatest common factor. But since we're dealing with least common multiple, I get the greatest common factor and multiply by everything else. So multiply by 3, and 7. So we're going to go 4 times 3 times 3 times 7. Do me a favor, one of you guys multiply that out. What do you guys get for 4 times 3 times 3 times 7? 252. So that's a least common multiple. 252. Once again, you can make two lists as long as they need to be until you find at least a common multiple. So you're looking for the smallest common multiple, or you can do your prime factorization, find your greatest common factor, and then multiply by everything else. Which one do you guys prefer, the list or the prime factorization? Which one? The bottom. The bottom one? Alright, so the next question, let me do it downward. Let me take a look at number 22. Prime factorization of 18 is going to be 2 times 3 times 3. Right, we know how to get there, so I'm not going to explain how we got there. 27, I know it's 3 times 3 times 3. If I was looking for the greatest common factor, will be 9, right? 3 times 3. Greatest common factor. But since I'm looking for the least common multiple, I'm going to go greatest common factor and multiply by those that I was not able to get in a group. So I'm going to go 9 times 2 times 3. How much is that? 54. And if you guys make the list, 18 and 27, they both eventually get to 54. That's the least common multiple. And I'll be honest, greatest common factor is easier than least common multiple. Right? Greatest common factor was easy because it was a small number. Right? A factor, like if I was looking at question number 22, I'm looking for a number that goes into 18 and 27. That's greatest common factor, so I was looking for a small number. But least common multiple, you're saying 18 and 27 are both factors, so they both have to go in, so you're looking at a bigger number. Right. Greatest common factor were small numbers, least common multiple are big numbers. So I'll be honest, least common multiple is a little harder. Let me take a look at another example. Number 23, 40, I'm going to go 2 times 2 times 2 times 5. Alright, if I do the prime factorization of 40, I get 2 times 2 times 2 times 5. For 30, I'm going to get 2 times 3 times 5. I look for my greatest common factor, which in this case is 10. Right, 2 times 5. That's my greatest common factor, but I have to multiply by everything else. So I'm going to go times 2 times 2 times 3. Right? Times 2 times 2 times 3. 120. So the least common multiple is 120. I will recommend calculators because you're dealing with bigger numbers. But once again, get your greatest common factor multiplied by everything else. That will give you your least common multiple. Does that make sense? All right, any questions? 24? All right, looking at number 24, the prime factorization of 20, I want to get that as 2 times 2 times 5. Prime factorization of 30 is 2 times 3 times 5. My greatest common factor is 10. So I find my greatest common factor multiplied by everything else. Basically what we were not able to get in a group. How much is 10 times 2 times 3? 6. Thank you. Once again, least common multiple, we're dealing with big numbers. Greatest common factor, what we saw last week, we were dealing with small numbers. Any other questions? Let me take roll really quick.